Okay, guys, in this little video segment, we're going to talk about probably what is the most commonly known model of the atom. Okay, so we've gone through this idea of what atomic mass is. We can find protons, neutrons, electrons. We know how to find weighted averages for our isotopes. So now the next piece of this kind of idea of atomic theory is, what does the atom look like? Now, we know that the atom cannot be seen. Okay, so there is no way that we can see them, even with our best equipment, our best technology right now. All we can really see is the vibrations of atoms coming off of computer generated graphics from what's called scanning tunneling microscopes. Okay, nothing from the naked eye can we see atoms yet. Okay, I like to use the word yet there. Now, because of this, we're constantly creating models of the atom. Okay, in the earliest time, we had people like Democritus who philosophically taught about the smallest particle ever known that everything breaks down into, and he called that atomna, which is the atom. And then we get to John Dalton, who started to build out atomic theory for the first time, first scientist to do it. Then we have people like Rutherford and Heisenberg and Bohr and a whole bunch of other, scientists who, through history and through the 1800s and early 1900s, really studied this idea of what does the atom look like. Okay. From that, we have built different models, okay? We have models that have gotten better at every step of the way, and we've landed on a model that, to our current understanding, is the best we have. That is not the planetary model, okay? However, the planetary model is probably what, beginning students learn about in middle school and high school science, because it's the last really good visual model for us, okay? And it actually has a lot of things that we can use. It's a very usable model for lots of things that we need. Is it a perfect model? No. Are there things that are not 100% true about it? Sure. And we'll discuss those in this unit. But it's a very usable model in lots of ways. And that's why it's still predominantly used in most of your entry-level sciences, because the model holds well for most of those things, especially if you're looking at visuals. So let's talk about that model and what it tells to us. One, in this model, we have electrons flowing in orbits around the nucleus like planets around the sun, thus the term planetary model. Now keep in mind, nobody has ever thought that the atom is a flat disk like our solar system. They think of it more as a three-dimensional pathway that the electrons would be orbiting. That was the original design of this model. Okay. In middle school, you may have heard the word shells. Like, how many different electrons on each shell, like Russian stacking dolls that had these little cases to them, okay? You may have heard that on the first shell gets 2, then 8, then 18, then 32. And usually after 18 or 32, everybody stops talking about it because they say, oh, you don't need to worry about past the first 4 shells. The reality is we have 118 electrons. There are more shells in the first 4. The reason why they stopped you there is because the complexity gets to a point past the first 2 or 3 in which they didn't want to deal with it. Well, we're going to deal with it in here, okay? Now, here's what I want you to do. I want you to take this word shells. I want you to put it in a tightly sealed envelope, stick it someplace, and never, ever, ever, ever use it again, okay? If you use the word shells to describe things on any assessment in my class, I will count it wrong, no matter how good the rest of your answer is. Because I do not want you to think that these are hard shells that the electrons sit on. Even the planetary model, the scientists who developed this, never thought they were shells, okay? I don't even know where the word shell comes from. The better way that we should describe this, and the terminology you use for an honors chemistry level term, is the electrons reside at set energy levels. So highlight this, set energy levels, okay? So even in the earliest parts of this model, late 1800s, early 1900s, they believed the electrons resided at set energy levels around the atom. Now, they did believe that these set energy levels were spatially probably like an orbit, like planets around the sun, but they never thought they were riding on a shell of some sort outside there, okay? So we want to use the term set energy level because we want to focus on this idea of energy, okay? From the planetary model, we got a very, very specific new idea that electrons can only exist at certain amounts of energy. So electron can be at the right amount of energy to be in this energy level here or here, these two, all right? Now, the interesting thing is they can never be in between the two. So electrons, we have found, do not exist at any energies besides here, 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 here. So the space between this are these energy amounts between these key places. We never find electrons, okay? So it's almost like there's something determining where these energy levels sit, okay? This certain amount of energy. It's kind of like rungs in a ladder, right? If you climb up a ladder, there's a rung every, hopefully evenly spaced on a good ladder, and you never float between one rung and the next rung, or stairs on a staircase. You don't float between two, you're either on one stair or the next stair, okay? Same idea with electrons. They either sit on one or the other. They can't be floating between the two. That idea is the first time we talked about this idea of quantized energy, or a quantum of energy, okay? You might be thinking, wait a minute, there's a model out there called the quantum model for atoms. Is this it? No, okay? The idea of quantized energy, or quanta of energy for plural, actually started in the planetary model, all right? It was carried over into the quantum model of the atom, which we're going to be studying next, but it started here inside the planetary model. So the planetary model does have electrons residing at set energy levels or set quanta of energy, okay? So that's how the model kind of works.